So what to do some more examples. So here कुछ examples हैं. These are I'm doing it from दूसरी बुक है फ्लोसेंजा वाली, ठीक है. उसमें सब स्पेस टोपोलॉजी का सेक्शन है 3.1, ठीक है. सेक्शन 3.1 from दूसरी किताब अटैच्ड है, एलएमएस पर है आपकी मौजूद, ठीक है. Okay. So we yesterday talked about subspace topology, or some set. You can, if you take part of it, you also have, you can define a topological space by taking the intersection of that set with the open set. Okay? So before moving ahead, if I ask from you, what is the basis for standard topology on R actually? क्या है basis?
Open sets.
Open sets. These are open sets हैं, मगर कैसे open sets? These are open intervals. So इसके अंदर जो ऐसे समझ लें sets हैं या open sets हैं, ठीक है, वो either they are open intervals or they are union of open intervals. Basis होने का यही मतलब है, या तो open interval है या फिर open interval है. कौन से set? Open set. How about if I now go in R2 with respect to standard topology? Cross product. By the way, अगर मैंने visualize करना चाहूँ, basis elements are like elements an interval. And these points, endpoints are not included. So if I go in 2 dimension, okay, then on R2, what is the basis actually?
Cross product of open.
So it's cross product of 2 intervals. You say that A is less than B and C is less than B. Okay. If I make a picture of it, okay, then how does this picture look like? AB and CD, A cross B is basically such a rectangle. So such rectangles, the collection of such rectangles is a basis actually for our standard topology. Okay? Now, another thing that I want to now bring in, so इसी को हम इस्तेमाल भी करेंगे बार-बार, and that's how we usually try to represents the open sets in R2. That is that I can prove that instead of triangles, if you take say circles actually, this would also work. In other words, if you take the collection of circles, I'm not going to be rigorous actually. Okay? I'm not going to be rigorous. So this circle is in R2. The collection of all this, what you call circles, is also a basis. Rectangles be basis and circles be basis. In fact, you can take, I can show with the argument that I have shown that you can take any shape you like actually, closed shape, that would work. Weird shape. For example, you take, I don't know, you take maybe a heart, and you can say the collection of hearts is going to become the basis of R2 actually. So take any shape, it would work, but it should be closed. Okay? Anyway, but I want to just argue about circle. Now I want to just pictorially show that why it is a basis actually. Why it is a basis. So what is the first, what do you call, property of something being basis actually? So you're going to say that every point in that space is in some basis actually. So give me a point in R2. कोई भी point बता दें R2 में. You're going to say, just take this point for instance. So can you find a circle that contains this? I can draw plenty of circles actually that take it. समझ आ रही है? And so in other words, so if you give me this point, in other words, if I put together all of these circles, I can cover entire set. Okay? And this B is the collection of all possible circles, open circles actually that you can make an argument. Okay? So the first property is true that okay, you take a point and you can draw a circle and circle sits inside.
The circles are balls.
Yeah.
Balls or circles.
So here's the thing. I'm not talking about. Okay, so you are right actually. So we should say disk actually. This should be a better way. So you have to keep in view that I'm talking about. This is a very good point actually. That I must use the correct terminology. So I'm talking about everything inside of it. Okay. By the way, it's not difficult to write mathematically. So if you have this point, for example, if you have this point, let's say its coordinates and AB, can you draw a disk on it? So I can say, this disk is the collection of points in R2 such that x का A से distance calculate करें, y का B से distance calculate करें. So this difference should be less than or equal to, okay, basically less than or equal to, I don't know what radius you choose actually. So if you choose 1, you can say this is less than 1. If you choose R, this is less than R. So that's the collection of all points, okay, that are at distance AB, okay, less than R. So this border is not, included. Everything else is included. So it's a disk. It's a good point. Thanks for this. Okay. When I was saying, I was, not precisely saying that it's a circle, but like I had, this idea of disk in my mind. So you got to be careful. So you spotted very correctly actually that when you say circle is just this boundary. Okay. So how can this point be on boundary actually? So we must be talking about disk. So I'm taking the collection of the disks. The collection of disks. Anyway, so every point is inside some disk. Do you agree? You give me a point and I can draw, what do you call a disk around it. Okay? That contains that point. So the first condition of being basis is satisfied. How about the second condition? Second condition में क्या है? You need to take two disks. So let's say I'm taking two disks. So this is another disk and this is this. Okay? And then from the intersection I pick a point actually. Then can you tell me, can you think of finding, what do you call, a tiny disk that contains this point? So this is B1 and this is B2. Okay? So you can find a tiny disk that contains this point and is inside the intersection. Okay? By the way, I'm not being rigorous here. मैं ये नहीं बता रहा because you can ask that what is the radius of this. So I mean, it's not difficult to calculate the radius of this. I mean, if I give you the radius of this circle and radius of say this circle, you can think of finding the radius of this tiny circle. That's not difficult. Okay? But this shows that if you take B1 and B2 and take an intersection, so this disk is like the B3, which is inside intersection of B1 and B2. So this collection of disk is also, basis. So if you take, for example, now an open set in R2, okay, so either that open set is itself a disk or I can create it through disks. I can cover this through this. Color chart है किसी के पास? Black is it. So I can cover it through this. In other words, this open set is either this disk or the union of disks. That's what is the meaning of basis. बार-बार मैं repeat इस वजह से करता हूँ ताकि ये बैठ जाए पास. ठीक है? That if you have a basis of a space, that means that now every open set is either an element of basis or the union of elements of basis. That's what we are saying. Okay? So for R2, such rectangles is constitute a basis, हम कर चुके हैं, but we can think intuitively that this is also a basis actually. And you can similarly argue about any shape as I said actually. Okay? You take an ellipse, collection of ellipse, wouldn't that create what you call the basis? Create the basis again. Okay? So usually now a bag, whenever I will say I have R or R2 or R3 or so on and so forth, standard topology, then you have to keep in head that the open sets looks like either this. How about if you go in 3 dimension? What do you think? What would be this?
A sphere.
But again, you need to be precise. It's gonna be a solid sphere.
Yes.
Okay. It's not a hollow sphere actually. It's a solid sphere filled with the material actually. Okay? But the boundary is not included. Okay? We will define boundary later on precisely, but the boundary is not included. So it's like a you know,
Orange without
huh?
orange without जो होती है.
Yes. So orange without the it's peel actually. Okay? Before peeling it, so orange is hidden there. Okay? Roughly, that's what it is going to be. Okay? So in other words, if you are in 3 dimensions, every point is inside such a sphere. Okay? And you can fill the entire space with such spheres. Okay? Okay, 2024 mein, the one of the highest prizes actually that was given, Nobel Prize I guess, that was given was on this problem that if you take for example some space in Rn or maybe R2 R3, okay? So R3 आपके पास है, so we have a box actually, okay? How efficiently you can have more and more spheres within that space actually. So it's a packing problem. They solve this, they create this packing problem. That is the best way to, and it turns out roughly that वो जो ready पर दिए इकट्ठे करके रखते हैं, the effective way to pack more and more space in the 3 dimension, the ready वालों को already पता है, it's like this pyramid actually, you make this pyramid out of it. Are you getting the point? Anyway. So R3 के लिए जो bases हैं in this manner with the standard topology are going to be. Can you make this picture in your head actually? How does this picture looks like? ठीक है? ये front है sphere का और this is back actually. ठीक है? With such spheres without boundary, ठीक है? Collection of such spheres is the basis for R3 actually. ठीक है? So in 1 dimension, I'm going to usually use intervals, collection of intervals as basis, disks without border as basis, and an R3 spheres without borders in R3 actually. Okay? Okay. Now using this, you can now create all kind of interesting topologies of the spaces. So R2 is a topological space. Okay? R2 is a topological space. It's not standard topology. Topology has bases and disks. Now, let me take a subset of R2. Okay? So give me a subset of R2 actually. Give me a subset of R2. Say for example, let's say, so here's the thing. Let's start with a line. Okay. Let's start with a line. So this line is a subset of R2. Agree? So this is a collection of X, Y, Now, in other words, if I take X to be R2 with a standard topology, और एक subset लेता हूँ जो हमने कर लिया था Y, which is this line actually. ठीक है? I don't know. Y is this collection of points such that Y equal to X. It's just a line. Okay. Now, is this subset a topological space? So if you want to create or turn a line into a topological space, how does the open set in a line would look like? कैसे दिखेंगे? कैसे मालूम करते हैं हम? Sorry, y no the topology on y is collection of y intersection open sets where O is open in binding R2. So it's the intersection of line with R2. So can you tell me that how does these looks like? I just want to have a feel for this. So you're gonna say okay. So you're gonna say that okay. Now take what do you call this line and take for example open set. So R2 में open sets कैसे होते हैं? So they looks like this. So the intersection of this disk with the line is this line segment actually. ठीक है? So this is basically the collection of line segments. So you take open set, या तो वो intersect करेगा, नहीं करेगा. अगर ये intersect नहीं करता, this is the empty set. But if it intersects, then you have this collection of line segment actually. ठीक है?
अगर वो टच कर रहा है
क्या मतलब?
1.8
Then 1 point actually. That's a very good point actually. That's a very good point. That what if the disk is just touching, but just touching is going to be a bit problematic actually. Think about it because
Boundary
it's
line.
open.
Boundary.
But you know, so it's going to be line segments actually. It's a collection of lines. So these are line segments. So in other words, now if I ask from you, is line a topological space? I'm going to say, आपका जवाब क्या होगा कि हाँ लाइन भी एक टोपोलॉजिकल स्पेस है और वो अपनी टोपोलॉजी इनहेरिट करती है किससे? R2 से. तो फिर और अगर मैं आपसे पूछूं अच्छा जी अब ये मुझे बताएं कि उस लाइन के अंदर ओपन सेट्स कैसे दिखते हैं? So you're going to say line segments. So these are the open sets. So see? So not only you know that line is a topological space, but you also know that how does the open sets work. How about if I take a circle? You say this is S1 actually. Okay? It's a hollow circle. X, Y, such that ये ऐसे points का collection है such that x square plus y square is some, I don't know. So I can make this. Maybe you should make it here. It doesn't matter. मैंने एक circle बनाया at origin. तो इसकी equation क्या होगी? X square plus y square equal to some r square. ठीक है? This is what. Now, is this collection of subset, जिसे usually हम S1 का नाम देते हैं, ठीक है? Is it a topological space? Is it a topological space? हम कहेंगे कि let's see that whether it is a topological. It is a topological. It's a subset actually.
Yes, sir.
Of R2 और R2 पर topology है तो subset पर भी topology है, ठीक है? मगर इस टोपोलॉजी में अब ओपन सेट्स कैसे दिखते हैं जो मैं मालूम करना चाहूंगा तो मैं क्या करूंगा पॉइंट्स कैसे मैंने से ड्रॉ अ डिस्क
Yes, sir.
ड्रॉ अ डिस्क ठीक है so when you draw a disk what is the intersection of this disk with this circle so it's this arc actually ये छोटा सा सेगमेंट है ठीक है समझ आ रही है बात so इसके जो pieces हैं so these pieces are open sets actually. Okay. So if someone asks from you, you know, or if now you can realize that circle is a topological space. And if I say that, how does in the open sets in the circle looks like? They are these line segments, curved line segments actually. Okay. That's how they look like. Give me any picture actually now. Think about it. Just give me any picture in R2. Huh? So let's say a wave actually. Let's say, is it topological? And you can ask that, you know, I don't know, maybe something like this. So why this is a topological space? So, you You can say that, okay, how does the what would be the, now you can see actually, because how does the open sets looks like? You know, the pieces,
Yes, yes, same.
segments. Because I can draw
Yes, sir.
a ball, a circle, and it's gonna be pieces. By the way, what if I draw such a disc actually?
Parable.
Then it's not just one part actually. So this piece,
Yes, sir.
union this piece
Union.
is such a, okay, is such a, so it's not just pieces there, but such pieces actually. So their collection can also be. And same is true with the circle. Circle के साथ भी अब यही कर सकते हैं. So for example, if I draw a bigger disc actually, that looks like this, huh? Maybe. So you also can have, what if इसमें अगर दो pieces मुझे चाहिए तो कैसे draw करूँ? What do you think? Ah yes. क्यों नहीं हो सकता? हो सकता.
सर ये नीचे से सर
So how about play this trick? Let me give you.
नीचे से हो सर
कैसे?
नीचे ऐसे वर्टिकली से गोल बना के वर्टिकली
Origin से close नहीं
नहीं. Here's a little thing. Why not? Think about that. By the way, एक चीज तो हम कर सकते हैं. So if you have these open sets, then the union of open sets is also open. You don't need to justify that.
Yes.
You know, through that. But you can also think of that. Can we have a circle that joins two line segments? I don't know whether it is possible or not. I mean, you can think about that. Okay, so in that manner, you can think of any picture in two dimension, and that's a topological space. Okay. So now you see another perspective of looking at. But you have to keep in view that topology is topology inherited from the underlying space actually. वो जो parent space है, उससे topology inherit होगी. ठीक है? How about if I go in 3 dimension? Okay? And I draw a line in 3 dimension. Is this a topological space? Yes. कैसे? So if I ask from you that, give me the open sets in this, so how does this look like? So you're going to say that, now I have to draw the sphere. Okay? Now this sphere is not intersecting with this, so that intersection is ambiguous. But let's say I'm drawing a sphere, which is kind of piercing. So this line is kind of piercing through it. It's just pierced through it. Okay? So what is going to be the intersection?
of these parts.
So again the line. What would be the common thing between the sphere and the line? It's going to be line segment. It's going to be line segment. Okay? So line is also a topological space. Okay, this is trivial. Huh? How about I take a sphere instead of taking. Let's just start. Maybe I shall start with a slender. Let's say, is slender a topological space? Is slender a 3-dimensional object? It's a 3-dimensional object. And it's a 2-dimensional object, but sitting in 3 dimension actually. Okay? Because इसको express करने के लिए only 2 quantities are enough. Anyway, but okay. So this is a subset of R3. Is this a topological space?
Yes, sir.
The answer is yes, sir.
Yes, sir.
How does the open sets look like? So it's like take a cylinder, a glass ले लें, कुछ भी ले लें, and let's imagine that this is a cylinder or a box, whatever you call it, okay. And you have some spheres that are piercing through it actually, okay. Sphere इनके साथ intersect कर रहा है. So when it intersect, what it would be? वो कैसा impact produce करेगा? So it will produce some segments actually, the parts of the segment, tons and tons of parts. So each sphere when you draw is going to have an intersection onto the surface of the sphere, and it will leave its impact. Okay? It will leave its impact. So you can imagine in your head actually, it's difficult to show that. How does this impact is going to be? I mean, अगर मैं ये remove कर दूँ तो I can see its impact here that it is going to be some part actually where, फर्ज कर देना, अब ये imagine करें, you have this sphere thing made up of white paper or something like that, ठीक है, not sphere but this cylinder, ठीक है, और white paper का बना हुआ है, और जो आपका sphere है that is colored actually, and then you say for example उस sphere को pierce करवाते हैं, ठीक है, घुसाते हैं, intersect करवाते हैं, किसके साथ, सिलेंडर के साथ, तो वो अपना असर छोड़ेगा. अगर वो जस्ट टच कर रहा है, थोड़ा सा उसके सरफेस को टच कर रहा है, तो इट विल लीव यू नो ऐसे समझ लें ये पार्ट ऑफ सिलेंडर जो है ना, इट वुड बी कलर्ड एक्चुअली, ये कलर हो जाएगा, ठीक है ना. यानी मैं हाथ लूं अपना, टेक दिस हैंड एक्चुअली, और मैं कलर्ड बॉल लेता हूं, when I touch it what will happen with the hand, so it will leave an impact, एक डिस्क बना देगा, एक शेप बना देगा, and that shape is basically the intersection, and hence that is the open set actually, ठीक है. So R3 is a cylinder is the open set. So any sphere. How about yourself actually? Think about yourself. We are living in 3 dimension. Let's ignore time for now. So we are the living topological spaces which are moving. Think about it. So what are the open sets in our action? So you want to say what is the open set in my head? So take a sphere, okay, and then you intersect it, and it will leave some impact, and that is the open set. So in other words, you can. So see that I can imagine that each part of my surface, is like what do you call? Is like an open set or the union of open sets, because that can be covered through spheres actually. ठीक है. आपको स्फेयर्स में गुम किया जा सकता है ना, यानी आप बीच में खड़े हो और फिर स्फेयर्स भर दें चारों तरफ से, ठीक है, तो स्फेयर्स कैन कंटेन, ठीक है, इन अ सेंस. So you are a topological space. So almost anything, it would be even a difficult thing to think actually that हाँ ये हो सकता है जैसे, और वो कल जो हमने एग्जांपल्स भी थोड़े से किए थे प्रॉपर्ली इस सारे, उसके बाद वो भी हम कर देंगे कुछ एग्जांपल्स, ठीक है. और मैंने कहे थे 3 एग्जांपल्स में से 2 किए थे हमने और एक छोड़ा था, दूसरे को मैंने कहा था कि आप देखिएगा, ठीक है. When you see those examples, कि पहला जो एग्जांपल किया था उसमें भी ये वाज़ेह हो गया था, you can have open sets that are open in subspace topology, but it is not necessary that they are open in parent topology actually, ठीक है, parent topology. In this manner, you see everything is the entire universe is a topological space. I'm not making this up actually. I mean, one of the the bigger physics problem that people are interested in knowing is that what is the topology of the universe? What is the shape of the universe actually? Okay? We still don't know what is the topology of the universe. Approximation ये है कि जो known universe है, when we observe it, it looks like something flat. What is the current approximation is that the universe is flat. But flat, that's too simple. Think about it. जैसे अर्थ फ्लैट लगती है, so आप किसी मैदानी इलाके में खड़े हो जाएं, everything is flat. So you go where you have flat earth or something. ठीक है? Why it looks flat? Because what we are looking is a very small part of the earth. So if you take a gigantic object, ठीक है, like a sphere, और आप एक चूंटी हैं, तो चूंटी से भी कोई कम चीज है जो स्फीयर पर मूव कर रही है, तो वो क्या एक्सपेक्ट करेगी कि कैसे say that's flat. So maybe हम इस पूरी कायनात में एक चूंटी की तरह, and with our telescopes and with our mathematical equations we kind of see through that how does it looks like, and it turns out that कि हमारा math हमारा data में ये बताता है universe as a whole is something that is flat. Maybe we are wrong, who knows. That's an interesting question. So is the topology of this the entire universe? Okay, maybe some of you would be interested in that. Let's find the topology. Let's find the shape of the data. Okay? Even those who are interested in machine learning and AI. Okay? These days you have this entire area of data science is called the topological data science actually. So you have a data, you're gonna say what is the topology of that data? Because once you visualize that data, once you look at its topology, it is going to reveal a lot of things about that data. Okay? But it's not that bad actually. These are useful set of ideas. ठीक है? Are we happy with it?
Yes.
तो अब थोड़ी सी वो बोरियत कम हो या पता नहीं क्या कर रहे हैं. You start seeing things, but the thing is that you got to learn ABC before reading Goethe and Dickens and Shakespeare and Bataille and all these people. You got to learn ABC Alif Bata. What we are learning is ABC and Alif Bata. ठीक है? और थोड़ी सी मेहनत है, थोड़ा सा बोरिंग भी है, but interesting है? Interesting भी है. Thanks. ठीक है? Usually topology जो है,
आपकी PPT जो है interesting है जब.
if you ask from the mathematicians, ठीक है, पाकिस्तान में पढ़ने वाले especially, what is the nightmarish subject that we have learned? They're gonna say topology. और ऐसा nightmarish है कि इसके बाद फिर कोई सब्जेक्ट जो है ना, जितना भी abstract हो वो nightmarish नहीं लगता, क्योंकि ये सारी साइंस जो है ना सोचने समझने की खत्म कर देते. What happens is usually, so when we say for example learn topology, typical in desi context, वो सिर्फ theorems and proofs, then you don't get anything. But the thing is that it is necessary to learn those theorems and proofs. सिर्फ ये हवाल नहीं काटना है, हवाल आसान है. When you want to actually think, justify the things, you have to work hard. ठीक है? Let's get back to the work. So we saw tons of subspace topologies. Okay. By the way, how about a donut? So the donut का example रह गया छोटा सा. How can I get a donut? Is donut a topological state? It is. How does the open sets looks like? It's like the spheres touching the skin of the donuts. The balls touching us. We are seeing through this. जरूरी नहीं कि सिर्फ टच करें, घुस भी सकते हैं अंदर. ठीक है? ये भी आपने समझ लिया. ठीक है? But when they touch actually the what do you call अच्छा जब ये घुसेगा स्फीयर तो it is going to give a piece of a donut. ठीक है? Think about it. Think about it. यदि आपके let's imagine too difficult. So फर्ज कर दें that I have मैं एक मट्टी से ड्रॉ करता हूँ एक डोनट और फिर उसके साथ एक स्फीयर भी अटैच कर देता हूँ. So you will have something in common between donut and sphere. अगर मैं एक sphere draw कर दूँ, ठीक है? And they both are sharing basically the parts. So there is going to be the piece of the donut actually that is going to be shared between sphere and donut. ठीक है? And that piece is a open set. That's what because what is the intersection between this sphere and donut? That is going to be that piece actually. ठीक है? तो अगले दफे जब भी when you eat a donut, when you eat anything, what you are eating is open set. ठीक है? Okay. So you have very good pictorial things here. ये section 3.1 पढ़िएगा. ठीक है? Try to get it. Okay. Is the next thing. Okay. How much time do we have? 25. So let's try to. So this is so what we are doing. सबसे हमने पहले start कैसे किया था? So we defined topology, ठीक है? And then we saw examples of topology. Then we did bases actually. इसका क्या मतलब है that how you can construct topology from some elementary things actually. कैसे छोटे-छोटे से particles लेकर you can create the everything. ठीक है? And then we said that if you have topological spaces, how you can create new topology out of it. ठीक है? And तो एक तरीका हमने कौन सा देखा? To create new topologies, we saw that basis is like the elementary things. ठीक है? You are creating also topology through basis. But one way that we did that you can take the product of topological spaces, and that is another topological space. And then we saw that if you take one topological space and you consider the subsets of it, okay, so there are lots of topologies sitting within what do you call topology, okay, the subspace. Another thing that I want to do, and maybe I'll keep on doing it in next classes as well, as an interesting thing, that is the quotient topology. So this is section 3.3 from Adam Process law. This is on quotient topology. Okay. Here is what does this quotient topology is all about? Now we are start doing the stuff that I talked, say for example in first lecture. जैसे जैसे ये बुनियाद बनती जाएगी, then we can see that what all this is useful for. Let's imagine that I have a piece of paper. ठीक है? So this piece of paper, and let's say that I identify these sides actually. So these two sides are same, and these two sides are same actually. ठीक है? और इन आइडेंटिफाई करने का क्या मतलब है? आइडेंटिफाई करने का मतलब ये है, टेक दिस साइड, ठीक है, रोल इट, इस पेज के तौर पे समझिए, टेक दिस साइड, roll it and glue it. Can you give me a piece of page? Yeah. Okay. So I'm taking this piece of paper, okay, and then I'm identifying these sides. And identify करने का क्या मतलब है? That I am gluing these ends actually. So when I glue these ends, what you gonna get? You get a cylinder actually. So जब आपने इनको glue कर दिया, ठीक है? So I've glued them, ठीक है? अच्छा, glue करने का क्या मतलब होना चाहिए? What do you think? Mathematically, what should be the meaning of gluing actually?
एक ही end point starting और ending को start और ending
glue करने क्या को अगर मैं mathematically मतलब देना चाहता हूँ, क्या मतलब होना चाहिए?
कनेक्ट
करने का यही मैं पूछ रहा हूँ, कनेक्ट करने का क्या मतलब होना चाहिए?
सर कोई काटी पीटी नहीं करो फिर इसको।
काटी पीटी तो कर रहे हैं ना। तो जब आप ग्लू कर रहे हैं तो आप काटी पीटी कर रहे हैं। ग्लू करने से मुराद है कि ये जो एंड पॉइंट्स हैं, यू कैन सी दिस मैथमेटिकली, कि हम ये कह रहे हैं कि ये एंड पॉइंट मिल चुके से मुराद है कि नाउ दीज एंड पॉइंट्स are not end points, but these are the common points actually. ठीक है? Not intersecting, बस इनको ये जो इसका end point और इसका end points हैं उसको मिलाकर we just creating one line. ठीक है? आप इसको यूं भी समझ सकते हैं कि this is a line, ठीक है? So line is a set, मगर ये ऐसी line है जो कि इस इन पॉइंट्स को भी कंटेन कर रही है और इन पॉइंट्स को भी कंटेन कर रही है. So that's what it is. Anyway, so that's what we did. जो वो मैथमेटिकली लिखूंगा आप समझ जाएंगे, ठीक है? So I glued it, ठीक है? अच्छा, इसको मैं इससे आइडेंटिफाई कर रहा हूँ और ग्लू कर रहा हूँ. So I get a cylinder. How about मैं इस साइड को इस साइड से आइडेंटिफाई करूँ? इसका क्या मतलब है? मैंने इनको ग्लू किया, इसको ग्लू किया, and I got this, and then you know what I'm trying to do, imagine अब ये इतना flexible नहीं है, but what I'm trying to do is to basically इनको मिला रहा हूँ. So what you're gonna get actually? You're gonna get a donut actually. That's a donut actually. ठीक है? So in other words, a donut, इसे मैं कहूँगा donut is a quotient of this paper actually. That's what is the meaning. Donut is a quotient of this paper. Slender is also a quotient of this paper. ठीक है? Slender को भी में. So anything that you can create out of it by gluing and doing something, that's a quotient of it. ठीक है? So anything that I create, so quotient से क्या मुराद? I'm gonna take a topological space and I'm gonna take some part of it, and then I'm gonna do that. I'm gonna glue them together and I'm gonna see that what new shapes I'm getting. Now those new shapes are the quotients of the old shape. ठीक है? So like the slender is a quotient. ठीक है? So here's the thing. This is a topological space
Yes, sir.
in R2, and I created this new topological space actually. ठीक है? And that's a different topological space. And then I, fold करके और donut बनाया, so that's another, topological space actually. And I can create all kind of things out of it, and then we're gonna see this actually. ठीक है? So ये हो गई बात, हवाई बात. Now we want to do precisely. ठीक है? When you are talking with, say for example, public, you can talk in this one. Let's have fun and do this and that. ठीक है? But when you are talking with a mathematician, you're gonna say, tell me what's the math of it. ये हवाल ना काटो. Tell me the maths of it. Okay? So here's a definition. Here's a precise definition. ठीक है? The precise definition goes like this. So let X be a topological space. So take your favorite topological space. By the way, here's the thing. How about if I take a line segment actually? This line segment is flexible. Okay? And how about, so you already can imagine that. How about if I take this side and roll it over and I glue it?
Rectangle.
Rectangle, circle, star.
बहुत सारी shapes. So all those shapes are basically what? Okay, whatever the dimension means, okay, let's not get into that. But I can get what you call a curve. So this is a line. So I can take this side. So it's like I can take this. ये phases हैं. I can take this and then I can glue these endpoints. So you can get a circle out of it. So a circle is a quotient of a line. Circle is a quotient of a line. ठीक है? So let's explain topological space. We're going to see more examples. And A, B, any set. So here's the thing. This is important to keep in head. A, B, any set. So it's not a subset of X. It could be something else. Okay? So X is a topological space, and A could be any set. Okay? And let's imagine you have a map P. Okay? Let's imagine you have a map P that takes the point of X and gives me the points inside A. So it takes the points of X and it gives me the points inside what do you call A. And let's say that this map is onto. In other words, it's a surjective map. Okay? It's a surjective map. Now, on A, I can define, or using this A, yes, using this A and X, I can define a topology on A actually. ठीक है, मैं A पर एक topology define करना चाहता हूँ. So here is a topology that I am defining. किस पर? A पर. You can view X पर already topology है मेरे पास. So this topology must be collection of open sets. ठीक है? So I'm saying ये U जो है ये open है. So it's a collection of U. It's collection of those U's for which if you consider the inverse image of the U, if you consider the inverse image of the U, this inverse image is open. So X की मदद से ही नई topology बना रहा हूँ A, ठीक है? So this looks abstract, but we're gonna get into some examples, and you will see that this is like gluing actually. Doesn't look like gluing. It's like, दिमाग की दही, but you're gonna see that this is exactly gluing. Okay? So X is a topological space. Take a subset. You just need an onto function between them, a surjective map between them. याद रखते हैं कि इस टोपोलॉजिकल स्पेस के अंदर कुछ भी हो सकता है, इसके अंदर नंबर्स भी हो सकते हैं, उसके अंदर नंबर्स भी हो सकते हैं, इसके अंदर फंक्शंस हो सकते हैं, उसके अंदर नंबर्स हो सकते हैं, ठीक है? इसके अंदर it could be anything, ठीक है? That's टोपोलॉजिकल स्पेस. अब जब भी टोपोलॉजिकल स्पेस आपके जहन में आए, so this is something that you have to do. Don't treat topological space as something abstract. जैसे ही टोपोलॉजिकल स्पेस आए तो एकदम से आपके दिमाग में लाइन, सर्कल्स, स्फीयर्स, डोनट्स, everything, ये सारी चीजें आनी चाहिए. So you just don't have to take X to be abstract. When you are making picture in your head, ठीक है? This could be a sphere, this could be a line, this could be a piece of paper, it could be anything. And this is another thing that I'm interested in. So I have a surjective map, or using this surjective map and a topology of X, I am defining a topology on A. और इस topology के अंदर क्या मौजूद है? ऐसे obviously subsets मौजूद हैं, ये subsets हैं A के. ऐसे subsets मौजूद हैं A के कि जिनके inverse image, ठीक है? याद है ना inverse image क्या होते हैं? इनवर्स ऑफ U से क्या मुराद होगी? ये वो X हैं X से A कि जिनके इमेज U के अंदर. That's what the meaning of pre-image is. That ये वो inputs हैं, ठीक है, कि जिनके images जो हैं वो. तो हम क्या कह रहे हैं? ये वो टोपोलॉजी है, ऐसे सबसेट्स ऑफ A का कलेक्शन है. इन्हें मैं ओपन कहूंगा कि अगर इसका इनवर्स इमेज जो है वो ओपन हो, इसमें X का, ठीक है? So the first thing that we need to do is what? We need to justify that it is a topology. So how can I say that this is a topology? So this is logical space on A, and this is called the quotient topology. Quotient topology. ठीक है? और this A is the quotient of X actually. So A is a quotient of X. What do you mean by that? So X is a circle or something, take a piece of paper, and then you have a gluing thing. This map is, we're going to see that it kind of roughly plays the role of gluing, and using this glue and X I am creating a new topological space A. तो अगर ये line है, so this ये जो A है ये क्या होगी? Circle by gluing the endpoints. ठीक है, समझ आ रही है? So A is like this. Now why this is a topological space? So we can prove, we should prove. How can I show that? Why the empty set should be inside this? Okay? Why the empty set should be inside this? तो मैं किस सेट का इनवर्स इमेज लूं?
empty का ही, empty का.
I would say that take empty set and consider the inverse image of empty set. So what is the inverse image of empty set?
Empty.
Right, it's empty. So is it in topology on X? It is in topology on X. ठीक हो गया? What should be
होगा ना सर?
हाँ? नहीं X में होगा ना भाई. ये subset X का. So this is P inverse of ए किसका सबसेट है? ये ओपन एक्स,
यस सर।
ठीक है, यानी जिसका आप इमेज ले रहे हैं पीछे वो ओपन होना चाहिए। तो हम ये कह रहे हैं कि भाई हमने नई टोपोलॉजी क्रिएट की है, ठीक है, अगर मैं इसके इमेजेस लूं तो वो इमेजेस जो हैं पीछे क्या होने चाहिए? ओपन होने चाहिए, ठीक है। हाउ अबाउट व्हिच थिंग शुड बी व्हाई ए शुड बी इनसाइड दिस? ए इसमें क्यों होना चाहिए? If I say A is inside tau A, A is inside tau A, why? तो जिसको आप चाहते हैं कि चेक करें कि ये वो टाउ में है या टाउ ए में है या नहीं, आप उसका इनवर्स इमेज कैलकुलेट करो। तो अगर वो इनवर्स इमेज ओपन हो एक्स की टोपोलॉजी में तो यू आर ओके। तो इनवर्स इमेज इसका क्या होगा?
X.
क्यों?
ये onto है।
Only onto function. Think about it. That's why we need surjectivity. Because if some function is onto, this means that the p of a is x actually. The image set of this is covering the entire x. Okay? No, p of x is this one.
या
P of x.
बराबर होगा।
Okay? So this means that p inverse of a is entire x. So since the p inverse of a is x, so, and this is inside the topology of x, so therefore it's a वो पहली कंडीशन सेटिस्फाई हो जाती है, therefore the a is inside tau A, ठीक है, now it is justified, ठीक है। What would be the second thing? ठीक है, let's take some subsets. Let's take, I'm taking u1 u2 un from tau A, ठीक है, and I need to show that in the intersection I equal to 1 to n, ui is also in tau A. So I'm taking these guys and I'm saying that this is what is in tau A. So can you tell me, अच्छा इसके tau, ये tau A में कब जाएगा? जब इसका जो pre-image set है I equal to 1 to n, ui वो किसमें हो? But can you tell me that what would be this pre-image actually?
Intersection of UI.
Pre-image of intersection of pre-image of the intersection is equal to the intersection. बल्कि ये हमने पढ़ा था ना, याद है? हमने किया था f inverse of a intersection b is equal to f inverse of a intersection f inverse of b. In fact, this is true for unions as well. So now you have, so if you have finite, this is still valid actually. Okay? P inverse of the intersection, and this is equal to intersection of I equal to 1 to n, P inverse of
UI.
मगर ये सारे UIs टाउ A में हैं, इसका क्या मतलब है?
तो उसका प्री इमेज
इन सब के प्री इमेजेस जो हैं वो
टाउ में
टाउ x में होंगे, ऐसे ही है?
यस सर।
अगर इनके प्री इमेजेस टाउ x में हैं और टाउ x इज अ टोपोलॉजी, तो उनकी इंटरसेक्शन भी
Tau X में।
This is going to be in tau x. तो अभी ये सिर्फ जैसे मैं जुबानी बता रहा हूँ, जुबानी नहीं बताना, when you are writing you got to write it in तमीज से लिखना पड़ेगा, तभी आप सीखेंगे भी और समझेंगे भी चीजें, सिर्फ जुबानी नहीं कहेंगे। So is it okay? Did you understood actually that why? यानी इसके यहाँ जाने के लिए दो justifications हैं, एक ये कि ये सारे टाउ ए में हैं, इसका मतलब ये है कि इनके इनवर्स इमेजेस टाउ एक्स में होंगे, एक्स की टोपोलॉजी में होंगे, और एक्स की टोपोलॉजी क्योंकि टोपोलॉजी है लिहाजा उन ओपन सेट्स की इंटरसेक्शन जो है वो भी टाउ एक्स में। So that's what justifies. And similarly, you can also show the union set. Now this topology is so this is indeed a topology.
सर हम जो टाउ ए के लिए कर रहे हैं ना सर, यहाँ टाउ एक्स के लिए
Tau x already है ना भाई, जब आप ये कह रहे हैं x is a topological space, that means you have a x and tau x.
तो फिर तो अलग से टाउ ए में होगा
इसमें
फर्स्ट प्रॉपर्टी।
नहीं, यहाँ मेरा कहने का मतलब है कि क्योंकि इनवर्स इमेज इसमें है, लिहाजा ये जो भाई साहब है एम्प्टी सेट ये टाउ। अब ठीक है, That's what I wanted to use. One मैंने यही कहा, ठीक है? Alright, so all of this is pretty useful. Now let's get to the, what do you call, the juicy part. इसके examples करते हैं, and we will continue examples अगली class में. कि भाई मुझे ये बताओ, ये किसी कोई भी सेट A की टोपोलॉजी में कब होगा? नहीं, X में ओपन नहीं, उसका प्री इमेज X में ओपन. ठीक है, तो अब मैं कहता हूँ मुझे एम्प्टी को शो कराना है कि टाउ A में है, तो मुझे क्या शो कराना पड़ेगा कि इस का जो प्री इमेज है वो टाउ X है. तो मैंने इसका प्री इमेज कैलकुलेट किया और मुझे पता चला कि इस सेट का जो प्री इमेज है वो एम्प्टी सेट है.
सर ये प्री इमेज कैसे आया?
ये प्री इमेज कैसे है? think about it. मैं आपसे ये कहता हूँ, tell me those x from x के जिनके images empty set में हो. Tell me those x के जिनके images, जिनके outputs जो हैं वो empty set में हो. तो empty set में तो कुछ भी नहीं हो सकता. इसका मतलब है कि ऐसा कोई x है ही नहीं. इसका मतलब है कि this is empty set. So that's what is. I mean, it's good actually you ask such trivial questions. I mean, it's not trivial question. I mean, पहली दफा जब कर रहे होते हैं, nothing is trivial. Everything need to be justified. जब आप आदत डालेंगे ना आहिस्ता आहिस्ता, ठीक है, जब आप expert हो जाएं टोपोलॉजी में, then you can, you know, what do you call, skip and do things. ठीक है, generalize. जब आप, when you are learning this for first time, you got to write everything. ठीक है, in words, in, you know, symbols, but you have to write it. ठीक है जी, तो हमने ये टोपोलॉजी जो है क्रिएट कर दी है. So let me just get rid of the proof. Proof is okay. आप देख भी सकते हैं वैसे किताब से. Now I want to give you the examples. I want to give you the example. Let's take some examples. ठीक है, कंटिन्यू भी करेंगे हम अगली क्लास में. कितना मिनट रहते हैं?
2 मिनट.
एक आध एग्जांपल हो जाए. एक आध हो जाए. So here is the thing. There's something interesting. So take entire rail line. And here take only 3 points. Say A, B and C. या कुछ भी रख लें. कोई भी 3 फेवरेट चीजें रख लें. And let me give you a map. So any onto map would do the job actually. So here's a map that I'm giving. So x is a real number. So I'm here. Okay? And I'm saying that, so this is 0. Okay? So I'm saying give me a real number. Real number कहाँ होगा? या तो यहाँ होगा, या तो यहाँ होगा, या तो 0 पे होगा. इसके अलावा कोई तीसरी पॉसिबिलिटी, या तो नेगेटिव होगा, पॉजिटिव होगा, या. So I'm saying that if this x is, say, what do you call, a positive number, okay? A negative number, doesn't matter. I'm going to say that this is A actually. And if x is 0, let's call it. And if x is positive, let's call it. Okay? If you have to make this picture in head, how does it look like? मैं क्या कह रहा हूँ? And this is an onto function actually. You can see or you can check actually that this is onto. Okay? Now, when I'm saying that P of x is A when x is negative, इसका क्या मतलब है? इसका मतलब ये है कि मैं ये कह रहा हूँ कि मैंने ये सारे numbers उठाए, इनको dots की तरह समझे numbers को. So these are dots, little circles. ये सारे आपने dots उठाए छोटे छोटे से, और उनको इकट्ठे किया और एक नुक्ता क्रिएट कर दिया, एंड दैट इज ए। So this entire line is being pointing. So it's like you have a light shining towards this point. They are emerging through this point. Okay. So you have this one point shining over the entire thing. So in other words, all of these points are mapped onto this point, which is A. ये बेचारा आ सके. This is B. And all of these points are mapped onto C. And they are mapped onto a single point. Okay, that is what you call C. तो हमने क्या किया, इसको आप यूं भी समझ सकते हैं. I took all of these points and glued them together and created A. And B is B. And I took all of these points. So ये line ली and kind of shrunk it. So यूं भी समझ सकते हैं, ये line है kind of shrunk here. I don't know. Cartoons has a big simulations actually. हाँ. Cartoon है ना, यूं तलवार बड़ी हो जाती है, फिर छोटी हो जाती है, and then तो my kid is these days watching what do you call, एक cartoon होता है, हमने तो नहीं देखा, तंग आ गया हूँ मैं तो उससे, बोबो बॉय. Oh goodness! I mean, they do all kind of crazy power things actually. So there is a guy जो के ना